So in this lesson today we'll be learning about how to conduct a hypothesis test for a binomial distribution. So let's get started on this question. We have a single observation x taken from a binomial distribution and a value of 10 is obtained, and we've been given the null and alternative hypothesis and we need to conduct a test. So the starting point here again is just quickly have your distribution on there, and in this case, and just bear with me a second, in this case what we have is a binomially distributed variable with 20 trials, and we don't quite yet know whether p is 0.3 or it is greater than 0.3. Our h0 is that p is equal to 0.3, and our h1 is that p is greater than 0.3. Our significance level here is 0.05, and our observed value, our observed number of successes, is equal to 10, because it says in the question a value of 10 is obtained. Now for this hypothesis test, because p is greater than 0.3, we want to find out the probability that x is greater than or equal to the observed value, which in this case is 10. I can't find that out directly, but what we can do is say that is the same as 1 minus the probability that x is less than or equal to 9. And at this stage I'm going to go over to the binomial tables and have a look at this probability. So n equals 20, p equals 0.3, so we're looking in this column here, and when I look at the probability that x is less than or equal to 9, I get 0.9520, which is this probability here. So this is the same as saying 1 minus 0.9520, which is the same as saying 0.0480. Now what do we do with this probability? We compare it to the significance level. In this case our significance level was 5%. This is obviously less than 0.05. Therefore, what we're saying is this is unlikely to happen under the assumption that p is equal to 0.3. Therefore we reject h0. There is evidence to suggest that p is greater than 0.3. Okay, right. Let's move on to the next question. So here we have a random variable that has a distribution of 20 and p again. An observation of x equals 3 is taken from this distribution, and we need to test at the 1% level whether p is 0.5 or p is less than 0.5. So again, the distribution is 20p. Our h0 is that p is equal to 0.45. Our h1 is that p is less than 0.45. Our significance level now is 1%, so 0.01, and our observed number of successes is equal to 3. So in this case we're going to work out the probability that x is, because h1 is less than, we're going to work out the probability that x is less than or equal to our observed value of 3. So now in this case I'm going to go over to the tables again and look in the right column. So we're looking now in this column here, less than or equal to 3 is this probability here. So this is 0.0049. Now what do I compare this to? I compare this to my significance level. This is less than 0.01. Therefore I reject H0, and the conclusion is that there is evidence to suggest that P is less than 0.45. This makes sense because we would expect there to be 9 successes under a 20 and 0.45 distribution. However, we only have 3 successes, and therefore this is significantly further away from what we were expecting for us to say that, well, P cannot be 0.45. Okay, let's have a look at the next example. So this one now is a contextual problem, and it's worth 7 marks, as we can see there. So we need to get the distribution from this, the hypotheses, get the significance level, and then we're going to conduct the test. Okay, let's have a look. Machine makes glass bowls and observe that 1 in 10 of the bowls have a hairline crack in them. So a sample of 20 bowls is taken. 1 of the bowls is cracked. Test at the 10% level of significance that the proportion of cracked bowls has changed as a result of the change in the production process. State your hypotheses clearly. So in this case, what we're going to have is we're going to define what we're measuring. X equals number of bowls with a hairline crack. Now, number of bowls with a hairline crack have a binomial distribution because we've taken a sample of 20. We don't yet know what P is, so we're just going to leave it at P. H0. Under normal assumptions, as things were before, P was equal to 0.1 because it says it is observed that 1 in 10 of the bowls have a hairline crack in them. Now H1, the hypothesis that the proportion of cracked bowls has changed. So it doesn't say it's increased, or neither does it say it is decreased, so therefore if it has changed, it's going to be probability that P does not equal 0.1. That is what we can say so far. Our significance level should be 0.1. Now what you realize is this is a two-tailed hypothesis test because P does not equal 0.1. So therefore actually what we should be comparing to in each tail should be half of this initial significance level given, 0.05. You just call this nu alpha. Now we've also been given that the observed number of successes, observed number of bowls with a hairline crack in them is 1. Now because this is a two-tailed test, I'm going to work out 2 probabilities. I'm going to work out the probability that x is less than or equal to 1, and I'm also going to work out x is greater than or equal to 1. So let's go ahead and work this out for a binomial 20 and 0.1 distribution. So we are now looking in n equals 20. We're looking in the 0.1 column, so we're looking down this column here. Less than or equal to 1, we can see here is 0.3917. So This is 0.3917. Greater than or equal to 1 is the same as saying 1 minus the probability that x is less than or equal to 0. So therefore this becomes 1 minus 0.1216. Now this is what is this equal to? 0. So I'll start there. 4. This is 0.8784. In both cases, what we can see is that this probability is greater than 0.05. This is greater than 0.05 as well. So therefore, if the probabilities that we have worked out for our observed value are greater than the significance level, we do not reject H0. We do not reject H0. And the conclusion therefore is there is not enough evidence to suggest a change in the probability of getting a crack. Right, so I hope this has been helpful. Thank you for watching.